Hi folks, what I'm going to do here is review how we can get different information from a quadratic depending on what form we're using. So here we're looking for the x-intercepts and the vertex of this quadratic function. And I'm going to work with this in two ways. So the first thing I'm going to do is I'm going to first find the x-intercepts and then see how I can use that information to find the vertex. Okay, so the way that we have so far for finding the x-intercepts of a quadratic is to try to factor. So that'll be step one, is I'm going to try to factor to determine the x-intercepts. And remember that when you're factoring, the first thing you should do is look for a common factor. And we see here that there is a common factor of 2. The other thing that we will often do is try to avoid having the first term be negative. So I'm actually going to factor out a negative 2, and I'm left with x squared. So this is going to be minus 6x, and this is going to be minus 16. Okay, so let's see if we can factor this. This now becomes fairly easy, okay, because two numbers that multiply to 16 and add up to negative 6, so 8 and 2 should do the trick. So here we'll have x and 8 and x and 2. We just have to figure out the sign. So they have to multiply to negative 16, which means 1's going to be negative. So it looks like it's going to be negative 8x and then plus 2x. Okay, so from here we can see that our x-intercepts are going to be 8 and negative 2. Okay, so by factoring, so once we put it in factored form, we're able to get the x-intercepts easily. And now we can find the vertex by first averaging out the x-intercepts. Okay, so 8 plus negative 2 divided by 2. Okay, so 8 minus 2 is 6, divided by 2 is 3. And then the y value of the vertex, we can just plug into the equation. Okay, so negative 2 times 3 squared plus 12 times 3 plus 32. Okay, so here 3 squared, 9 times negative 2, so negative 18 plus 36 plus 32. So here, what do we have? We have negative 18 plus 36 is positive 18 plus 32, so 32, 42, 50. Okay, so our vertex is 350. Okay, now notice if I did want to put it in vertex form, I actually can do this now. So if I did want to put it in vertex form, so I have all three forms, well, I know that the a value in vertex form is the same as the a value in standard form or factored form, so it's going to be negative 2. Here my vertex is 3, so it's going to be x minus 3 squared, and then my, in this case here, maximum value is 5, so plus 5. Okay? So this is how we can solve this problem, by first factoring and then averaging out the x-intercepts to find the maximum and minimum value. So number 2 is to first find the vertex, and the way in which we do that is we complete the square. Okay, so let's do that as a review on completing the square. So again, when we're completing the square, we're really only working with the first two terms. The plus 32 we'll only deal with at the end. Okay, so here I'm going to start by factoring out the negative 2 like I did before, but only from the first two terms. So here this becomes x squared minus 6x, and I'll worry about the 32 at the end. Okay, so now I have to create my perfect square, and the way in which we do that is I have to add and subtract half of 6. Okay, so I'm going to add 3 squared, but I also have to subtract 3 squared, since in the end I don't actually want to change the value of the expression. Okay, and of course the reason why we do this is because these first three terms give us our perfect square. So this is the same as x minus 3 squared, which we need for our vertex form. And then of course we still have the minus 9. Okay, and the last thing we have to do is clean things up to get it in vertex form. So the first thing I'll do is I'll distribute the negative 2 to both the first and the second term. So we've got negative 2 times x minus 3 squared. Negative 2 times negative 9 is plus 18. Okay, and here we have negative 2 times x minus 3 squared, and 18 plus 32 is plus 50. Okay, which we see is exactly what we got before. So our vertex, of course, is still 350. Okay, so now if we want to find the x-intercept, well, what we can do is solve this equation, since the x-intercepts are gotten by finding when y is equal to 0. So I'll set y to 0. So I have negative 2 times x minus 3 squared plus 50. Okay, and when I have it in this form, I can actually solve this equation using opposite operations. Okay, so I'll bring the 50 to the other side. So negative 50 equals negative 2x minus 3 squared. Okay, divide the negative 2, so we have 25 equals x minus 3 squared. Now to get rid of the square here, I take the square root of both sides. Here I need to be careful because when I take the square root of 25, I have two possible answers, both positive and negative 5. So x minus 3. And then finally I can find my two x-intercepts by first adding 3 to 5. Okay, so 5 plus 3. Or I can add 3 to negative 5. And we have as our x-intercepts x equals 8 or x equals negative 2, which is exactly what we found before. Okay, so just to recap, okay, to find the x-intercepts, at this point here we can factor the expression, and that helps us find the x-intercepts. And to find the vertex, the easiest thing is to just complete the square. Now, if I've already done either one of these, so if I've already found the x-intercepts, I can fairly easily find the vertex. Okay, and if I've already completed the square, or the function is given to me in vertex form, it makes sense to find the zeros by solving this equation. Okay,